My name is Jeff Semmens. I'm a senior sales engineer with InterSystems. And Steve Mallam, my compatriot, he heads a sales engineering team over in the UK as well. Typically, we have a slide that has like an agenda. I thought it was a little unnecessary because basically what we're talking about is two separate use cases. One that I've implemented here for a prospect that we're working through, and then another one that they've been implementing in the UK from a team that Steve will tell you about. So without further ado, we'll just sort of dive in. We don't have tons of time to go through them, so these tend to be sort of overviews with a little bit of a dive, and if you want to find out more information, just track us down later, and we'd be happy to talk more in depth on any of these. All right, let's go ahead and start. So the whole vision behind the use case that I'm going to be talking about today is the idea that if I am going to be creating the next great application in healthcare, the next breakthrough thing that really makes a difference in patients' lives or in other situations where patients are involved, I really need to focus on that and not have to worry about all of the how do I get the data into my application to actually do that work. That usually means that I probably want to talk in one standard so that my team can focus on what they're doing, their front end, their really, the special sauce of whatever your application is, and not have to worry about 15 or 20 different types of data coming in that they have to manage and do all the mappings and integrations for and everything that you have there. What they'd rather have is one standard, and since FHIR standard itself is probably one of the fastest growing standards out there on the healthcare side, my customer that I've been working with chose that one to say, you know what, all we want to do is talk to you in FHIR. If we need information about a patient, I want to do a patient query against and you give me my patient bundle with everything I want in it. And we go from there. And that was really their vision of how they want to keep going forward. And really the pain comes down from their point of view is that if you are trying to get clinical information, it comes in so many different formats nowadays. You have the original HL7 stuff, that then you have to do your mappings and get in somehow into your FHIR repository if you want it that way. You have native APIs, you have web services, you have CDA files that you'd have to basically figure out all the stuff about the patient and pull it in. So there's just a lot of work there. And in their case, they didn't want their guys focusing on that. Because if you do that, that is a lot of time spent for your team that's not focused on what your application is supposed to be doing. So I've always said for years that what InterSystems has been doing more and more is trying to take care of the plumbing so that you don't have to, so that you can really focus on what makes sense. And so a lot of this use case that we'll talk about in a second is really focused on that. This is just really a picture that I had to put together to say the same exact thing. So I'm not going to spend much time on it, but it's the whole idea that I'm getting data from a bunch of places. I don't want to care about it. I just want to get the data. And then the whole idea behind this is that we're now using, for this use case, we use IRIS for Health as sort of a FHIR hub, if you will. IRIS for Health will go out to wherever we get the data from. In this case, we're talking about an Epic installation. So the whole idea behind it was I want to get Epic information, and I want to pull it in and have it as FHIR resources. So let's talk a little bit more about just the use case itself. Again, I want to get the information from different EMRs, but my first one is Epic. I mean, they're a big one to go to, so I want to get the information from them first. So let's prove it that we can do that, and that's really what we did in this situation. The whole caveat: the Epic data should be gathered, stored as FHIR resources in the IRIS for Health FHIR repository. The client application gets all the data via FHIR requests, as I said before, and the FHIR repository data population is via. In this case, we use just the Epic App Orchard testing environment. So that's something that Epic has up there. You pay to use it. It's for vendors or other people who want to make access to their clinical data. And this is a way to say this is their supported way for getting at my data. So even though Epic is based on InterSystems technology, the last thing that they're going to let you do is directly touch their data. It's always going to go through some sort of format. And then the customer said that really what we're looking for as far as FHIR resources are these 11 FHIR resources. You know, patient one, allergy intolerance, clinical impression, so forth and so on. We need to populate those. There's already a lot of mechanisms within IRIS for Health to handle that, and I took advantage of those. But the next thing we had to do was really look at, okay, well, how can Epic give me that data? So we came up with a little spreadsheet. On the left is all the different FHIR 3 resources, and on the right is how Epic can map to those right now. So typically when you're talking FHIR, you know, a lot of times it would be nice if I could just say, I want all the patient information for this particular patient from Epic. And there's a nice syntax called like $everything that you can use in situations like that. However, Epic is moving towards a standard FHIR resources for all of their data, but it's not all there yet, so they don't support that yet because they're doing it bit by bit. As they do each one, they release that resource and it's available, and they have different formats. So if you look here on the table, anything in green is basically stuff that they have an STU3 FHIR resource that I could get at. What we had decided in the POC to use is we decided to store STU3, as that's the highest level of FHIR that we're storing right now in the database until next year. And anything in blue was a DSTU2 or FHIR2 standard coming through. And then anything in orange, they only had a web service available that happened to return some JSON content. So we had to do more work on that because I now have to do some more mappings and things like that to go forth. And then the one in gray is basically they didn't have any of it, and the only way to get to it was a proprietary API that would return some sort of flat file or some sort of stream of data that we decided was out of scope for this project itself. You know, let's just ignore that one. And that really comes down to, why don't I show you a little bit of what we built and how it works? Because the whole idea is somewhat simple. I want to go get the stuff, I want to pull it into our repository, and then I want to make it available. So to do this, I took advantage of IRIS for Health's interoperability. You know, we have support for a lot of different standards in there already. FHIR, of course, HL7, CDA, you know, all these different ways that we can actually pull data in. We were focusing mostly on FHIR resources or web services coming into us right now. And really, a lot of these other components that I have on this production are pre-built FHIR components that already come with the product. And I wrote anything you see here with the CDIP package at the start of it is pretty much what I wrote. And it comes in, and then it hits a number of these different, what I call extractor processes. And really, because I'm doing FHIR, I'm using a nice generic REST operation that all I have to do is populate a FHIR request message, send it to this operation. As part of the FHIR message that I'm sending you, it actually says what service I'm supposed to be hitting. So it has all the information for how I hit it and everything else. It goes out, grabs whatever the contents is to come back, and then returns it as, in this case, I asked for JSON formatted FHIR bundle coming back. Or if it's just a patient, maybe it's just the patient resource itself coming back. From there, I can respond back and save it into our FHIR repository. There are components here that I could have just called it to and done that, but there was actually a little bit more work when we looked at it, because any resources that I was pulling from the Epic side had all of the Epic-based URLs as part of them for any references or anything else in them. So we had to go through the work of also making sure that we changed those. And by the way, since we couldn't do $everything and get everything at once, we also had to iterate through any references we found and ask Epic for those ones as well. So a bit of work to go through. And the code looks something like this. So I'm iterating through. We kept it very simple for how we were going to figure out which patients it was. The whole idea was that I have a list of patients that I'm going to be seeing this day. So at the start of the day, the system will make a call that says, go populate all of these patients into the FHIR repository so that I can ask for clinical information about them during the day when I'm seeing these patients or when I'm doing something about these patients. So I had a little, I created a RESTful operation that accepts different patient IDs to come in from the Epic side, and I There are different versions of them, if I'm getting SDU3, if I'm getting DSDU2, if I'm getting web service. So just a structure that allowed me to grab that information for what I want to do. And then it's as simple as creating a new FHIR request message, setting all the different interaction and getting the headers, so there's sort of specific login information that I need to send to Epic, to the app orchard itself to log in correctly and use it. So I have authorization of my client ID, and then you have the content type, you have what I'm grabbing for in this first one, which is a patient, what service to use. So this is a definition for where in App Orchard the actual URL that I'm going to be hitting for their FHIR resource. And then I'm also passing in the ID that I want because I have an SCU3 ID that I'm passing in. Once I do that, I call our REST operation with that request, get back a response, and deal with it. Now, in my case, we have some nice structures internally. We have some models of all the VSDU3 and DSDU2 resources as object models within the environment already. So I was able to directly take that resource from JSON that I got back and put it directly into a model so that I can manipulate it. Because I want to do a few things like change out the base URL. I want to reset the ID so that it's my own ID and my own resource repository, things like that. Once I had done that, there's a nice little call that I can make directly to store it within our repository. And that will give me back, error checking and stuff like that if it couldn't validate it correctly or whatever it had to do. So that's just for the patient resource itself. And then I would go on and say, okay, well, I want all the allergy intolerance, which is actually going to be a bundle. And the bundle itself, I actually call another method that says, I want to save that SDU3 bundle after I get it. And it'll iterate through the entire bundle and do it correctly for me. The other thing to take of note is that I'm also calling a check references. So this is going through by the definition of the FHIR resource and actually figuring out which things are references that I need to look at and actually go get from Epic if I don't have already. So this is sort of boring to look at as code in some ways. So let's go ahead and watch this in action because that might be a little better. So we'll go ahead and send through a request, have it happen, and then go look at the trace very quickly. And to do that, I'm just using a simple REST client. I have this payload here, which is my JSON structure of what I want to send to it. And if I hit send, and hopefully networking and everything else works, then we should get back after a while, depending on the network speed here, a response. Now keep in mind, this is not just getting 11 resources. This is probably getting a couple hundred resources because of all the references within that first reference. If I was able to use $everything, that would be simpler because then I would actually I would be able to just say, just give me it all, and it should return one bundle to me, which should take, less time. So in this case, I've read 97. I do have 46. What we find out of those 46 errors are because there's some bad test data on the Epic side, it doesn't validate correctly, or it comes back with saying this is a bad message that's no longer here anymore. So that's to be taken as it's taken. And then from here, I can now go in and take a look at my message repository. Just go into the message viewer. I can say, okay, I just completed this thing. This happened today, right? This is the 24th, is it? Good. And we have the whole idea. I've passed in my payload. I have then asked for the patient. I have gotten back the patient. I've then stored that within our repository, which we're not tracing right here, but we can. Actually, I put in a couple trace statements to make sure that we knew what we were storing in here, that this really was a patient resource that I was storing in. And when it comes back, notice that any of the URLs actually have my URL with InterSystems in there as opposed to the original Epic ones. So that's part of the changes that I had to make. And then we go through the same thing. Here's the allergy intolerance. Here's the medication statement. Here's the observation, so forth and so on. Later on down here, quite a ways along, let's take a look at one of these. This is actually an encounter. So we have a bunch of encounters, and then here's probably one of the bad ones. data absent reason. So there's basically something I was expecting wasn't there. So there is some validation and things like this that's going on as well. And going through the whole trace. So you can actually trace every single one that comes through, figure out exactly what's going into your repository or not, that type of thing. And then at the end of this, if I want to, I can go back to my Rust client and say, well, I actually want to get everything. Well, first of all, I just want to get the patient. So I grab that. Here's all the patient information. All comes through fine. But I could also say, since we do support $everything, since it's in our repository, I can basically say, well, let's do a $everything on this. Takes a little bit longer, but much faster than if I had to do it. And it returned 237 different resources for this. Now, how I've built this before is also, I have, in my opinion, every single time I go and ask for a resource, I'm just blowing away what we already have and just replacing it, because this is sort of going to be a resource cache. You can design this in other ways using maybe some pub sub or something else to say, I only want to go out and get data out there when I know there's something new, and otherwise they can just hit my repository. There's a lot of different ways that you can do this going forward. So that's my use case.
Okay, so what I'm going to talk about is a use case we've built in the UK, and I need to give you a little bit of background on things that happen in the UK first, because I guess not many of you are British and wouldn't know the background. Historically, in the UK, health and social care have been two entirely separate organisations. So health clinicians don't talk to social workers didn't talk to clinicians. And that resulted in a few unfortunate situations where children who were being abused fell between the gaps in the organisations and weren't protected properly. So a few years ago, the government actually changed that, put a single government minister in charge of both health and social care, with the idea of bringing those organisations together and really making them work together effectively. So that's part of the project we're working on. The other aspect of the project is that we've got a national programme in the UK to adopt FHIR as the standard for healthcare communication across the whole of the National Health Service, the NHS. Up until now, we've been using HL7v2. About 10 years ago, there was a serious national effort to adopt v3, which was poorly supported by vendors, lots of incompatibilities, an awful lot of money was spent, and eventually it was abandoned. So when CDA came along, that you guys in the States all adopted, we just ignored that. There's almost no CDA in the UK. Very little IHE. XDSB, document registries, repositories, is about as far as we go with IHE. So FHIR was the big new thing, and the NHS has mandated that all projects going forward will use FHIR. Currently, STU3 is the standard. There is some DSTU2, and we are going to be adopting R4 and newer versions as it goes forward. So that's just a little bit of background. The other thing I want to mention is something that will be well known to any parent in the UK, is the Personal Child Health Record, or the Red Book. And if you were in Max's presentation earlier on, he mentioned this, but that's a picture of it. It's basically a red book about ear big with lots of information for new parents in it, lots of really good information, and all of the forms and all of the information that is captured when a child sees any healthcare or social care practitioner is held in this book. And the parent or the guardian of the child keeps that and carries it around with them everywhere they go. And anytime you see a doctor, if it's a vaccination or just for a checkup, it all goes in this book, which is great until it gets rained on, because it's raining on the way to the doctors. This has been in place for, well, crikey, my oldest kid is 26 and we've got one for him. I don't remember if I had one or not, but it's been around for a while. And there is a determination to make this electronic. Obviously, parents of young children tend to be fairly young, tend to be fairly technically savvy, so we wanted this to be an iPhone app, not a big red piece of paper they have to carry around. So the next couple of slides are actually NHS slides, talking, and forgive me, I can't point to both screens at the same time. I don't even know if I can point to this screen. The strategy that the government has put in place is, over the next few years, to go from a situation where healthcare professionals don't really have access to all of the information unless the parent has the book with them. The situation where that child health record is on paper and nobody really has a single view of the whole of the child's record, to the point where we have standards for exchanging information, FHIR. We have an interoperability layer in place for applications to use to access that data. And then we can replace the paper processes and actually have proper safety protocols in place for when children are at risk. That way. So again, this is the whole of the NHS strategy. The pieces we're focusing on for this project are enabling parents to have, this is not working, an online record of their child's health and development and to be able to enter information into the process. And for healthcare practitioners to be able to see the whole of the child's record and get up-to-date information at any time. So we are working with the NHS in a region in the northwest of England called Lancashire and South Cumbria. Lancashire is now, it's a relatively urban area, lots of kind of small cities and the population, like 150, 200,000 population cities, so a total population of about 2 million. Historically, Lancashire included the cities of Manchester and Liverpool, which are obviously a lot larger, but they were kind of separated off in the 70s. South Cumbria is on the edge of one of our national parks called the Lake District, so that's a lot more rural, much smaller towns and villages. But in both cases, they're fairly depressed economies. They're historically industrial towns, so there's a lot of underprivilege in these areas. And then for reasons I'll talk about later, London, which is like 400 miles away, got added into the mix as well. What we are doing is we are providing a central hub for messages about events in a child's life to be published, and then systems that need that information can subscribe to the messages and get those messages sent to them on demand. So rather than having one central set of information that everybody has to read, or a standard integration engine where we fire off all the messages to everybody all of the time, it's a publish and subscribe model. The aim is that we will be starting to go into production in November and aiming to have around 70,000 mothers registered with the system by the end of next year. All based on FHIR, and the NHS has defined the set of messages that are supported. So notification of birth, height and weight measurements, blood test results, the newborn infant physical examination results, vaccinations, immunizations, all those sorts of things. But in principle, what we have done is built, using IRIS for Health, this central hub for subscription and publication of FHIR messages. We're using our standard OAuth 2 security. In the demonstration I'm going to show you, I'm using our OAuth 2 provider. In the real system, we're using Microsoft's provider because the NHS already has that available online. Using our standard FHIR interoperability, using our standard publish and subscribe facilities. Obviously relying on the audited, reliable messaging of IRIS for Health, Health Connect, everything we've had for years. Using both DSTU2 and STU3. I'll explain why we're using the repository as well in a minute. And we're supporting both JSON and XML. So this is one schematic of the system. At the top, we have all of the publishers and subscribers, all going through OAuth 2 and encrypted with TLS. In the blue box, we have IRIS for Health. And really, the important bit in the middle, we have our event router. That's the production that manages the messages. We have a set of RESTful FHIR APIs. And again, for reasons I'll talk about, some non-FHIR RESTful APIs, basically to support systems that don't yet actually do everything that they need to with FHIR. And we have the FHIR repository. The reason we have that FHIR repository is for systems that subscribe to events about a child after the child has been alive for some time and a number of events have already taken place. So if we were just passing the messages around as they came in, there'd be no way to go and reconstruct all of the data. So we store all of the messages in our FHIR repository so that a subscriber can say, give me everything you've got about the child already, and then give me any new messages as they come in. And this is a slightly more complex picture of the architecture. What this is showing, and it would be great if I could point at the screen for you both at the same time. Actually, I'll use the mouse. Does the mouse work? I can't really see it from there. Okay, so at the center, we have, if I turn my head, the microphone doesn't work. We have at the center the InterSystems Event Management Service based on IRIS for Health. And what we're showing here, it'll be easier to point. Over on the left-hand side, we have EMIS Web. EMIS is a software company that is one of the market leaders in primary care software in the UK. So they have huge market penetration in general practitioners' offices. And they also provide software for child health services and health visitors, community nursing. So a lot of the messages, and the box on the left shows which, a lot of the messages are being published by EMIS in one form or another. But there are several different systems there used by different organizations. So EMIS is also a subscriber for a lot of messages. We have at the top in the middle eRed Book, which is an application developed by a company in Edinburgh in Scotland. And that provides both a web browser application, iPhone, Android mobile applications to replace that paper physical book. So parents can register and with appropriate authentication, get access to their child's records through the app. At the top right, we have a set of national screening services. Things like the newborn hearing tests and the physical examination results are performed by central services rather than at the family doctor. So they're published through a separate system. And then at the right, it came in that while we were working in the Northwest, NHS organisations in London realised they needed something very similar, and our customers spoke to each other and agreed that they would share the same system. So we have slightly smaller usage, but Serverlec Rio, which again is a kind of community nursing and mental health system, is using the event management system we stood up for their messages as well. Two other things I need to mention on here. PDS at the top is a national patient demographic service that the NHS already has, and we can use that by sending in a patient's NHS number, which is their national identifier, to get access to other information about them, name, location, and which family doctor they're registered with. So, in terms of subscribing to messages, I'm going to show you a real example, but just for the slide, the NHS has defined a FHIR bundle specifically for subscriptions with essentially a query criteria. In this case, ODS code is the organisation's code. Each healthcare provider in the UK has a single code from which they can be identified, and then a set of event codes. So what we're saying here is we're subscribing to these particular messages, whichever child they refer to, coming from that organisation. Right, I'm going to sit down for this. No, I'm not. So what I'm going to do here is just show you briefly the message flow before I show you the real demo. There's two different message types we support. We support both a push and a pull model. So the push model is for systems that can support posting FHIR bundles to a RESTful FHIR service. But not all systems can. Some systems can only provide a FHIR bundle on request and can send a simple notification. So I'm going to show both of those. In the first example, EMIS Web on the left, the GP software is going to publish some FHIR information that is going to go over to the eRed book and back over to all of the other EMIS software packages that are in the system. So the first thing it has to do is authenticate itself, sends a request to the auth server and gets the Java Web Token back. That is then all sent, and I think I'm only moving the red dot here, but the FHIR bundle is sent to the event management service where it is validated and stored in the FHIR repository. The event management service then asks the National Patient Demographic Service for more information about the patient, which doctor they're registered with, for example, and then matches that information against the set of subscriptions that we have so we can figure out where these messages need to go. Having determined that we need to send the messages to eRedBook and back to EMIS Web, we again have to authenticate against the Auth2 server, get the web token back, and we can then send those FHIR messages on to the correct destinations. Now, we haven't done any processing on those messages. Those are the exact messages we received. We're just forwarding them, but we're forwarding to the right places according to the subscriptions and storing them in the repository. And we're done. The other example is the National Screening Service here over here on the right, which performs simple blood tests, hearing tests, things like that on babies. And their system doesn't have the ability to post those FHIR messages. So when they want to publish a message, again, they have to authenticate against the Auth2 server, but then they send a simple message to a RESTful web service we stood up for them. And we then send a request back to them to go and retrieve the FHIR data. So that's more like a pull model. But again, we get that FHIR data back, we validate it, store it in the repository, and from there, the process is the same. We find out who the patient is, figure out which subscriptions, if any, apply, and then send those messages on to all of the endpoints that need it. So now I'm going to go into a quick demonstration. So what I've got here is, in the theme of the week, I am running our event management service in a Docker container on my laptop. In real life, right now, it's running in our data centers in the UK, InterSystems data centers in the UK, which we have two, one in London, one in Birmingham. The plan is to transfer that to at least AWS, possibly Azure as well, at some point in the near future, just as soon as the NHS works out its commercial agreement with Amazon and Microsoft, because they're understandably concerned that they can't predict the usage yet, and they might get bills for tens of thousands that they're not expecting and don't have the funds for. So in my demo environment, I have the event management service. I also have a second, if I bring it up, a second FHIR repository that we've created. How many times do you have to do a demo before it goes wrong in front of everybody?
It's usually only when it's live.
Yeah. The second FHIR repository we have is intended to just act as a subscriber for the purposes of demonstration. Obviously, I don't actually have a GP practice software sitting on my laptop, so that's purely for demonstration purposes. Before I go any further, because my laptop's running in about 3 different time zones just now, I'm going to go back into the message traces on the event management service and show you that there's kind of not many messages in there, just so that when I send them through and they have a time in, I don't know, UTC or British summertime or whatever it's set to, you'll see at least messages appearing. What I'm going to do is send in a bunch of test messages that we've created using Postman, which is an application that allows us to send the RESTful messages to the system. These messages are actually our genuine test messages that we've agreed with the NHS. So this isn't just an example. This isn't just an example. This is our real test case, our real test scenario. So if I look at the messages, the test I've got, unfortunately, I need 2 hands.
Can you use this?
Does this work? Is that working? Yeah. Okay, cool. I'll move that over here. So I have a set of test messages which includes the test messages to go and get the OAuth certificates. I actually have two sets of test cases, one that uses simple security rather than the OAuth. I'm going to be brave and run the actual OAuth tests now. That is going to make life more difficult for me later because I'll not just be able to log in and show you FHIR bundles in the system. I'll have to hack that, but you can see that. Looking at some of the messages, we've got the subscription message, similar to the one I showed you in the slides, but in this case, we are registering or subscribing to any messages for the patient with this NHS number. And obviously, we're going to create that patient. And then for each of the message types, we have at least one test. So if I pick one, allergies and adverse reactions notification. I can go and look at that message, and I can see that it's Child Health 03, allergies and adverse reactions notification. I can see where it's being sent from, Blackpool Victoria Hospital. I can see, where's the child information? I've zoomed in too far. There you go. I can see it applies to baby Hannah Bucas, the date she was born, her NHS number, and so on. Obviously, this isn't a real person. The one thing I do want to show you here, though, is also the metadata around the FHIR profiles we're using. So if I go and pick that URL out, and hopefully my internet's working as well, that's taken me to an actual National Health Service NHS website, which is telling me that it's a FHIR server, and this is being an auto-generated documentation about the FHIR resources that I'm using, which are described here in text and in code, and you can even go and see the Git history because these have all been open sourced by the NHS. If I go back and click up on one of the contents pages, again, just to reinforce how much effort the NHS is putting into FHIR, and it loads, this is the set of all of the APIs that are currently under development. And if you've been in the earlier sessions, you might have heard us talking about transfer of care, which is currently in beta, GP Connect, which is live, this project, Digital Child Health, which is currently at release candidate stage on STU3. But you can see how many different APIs there are. In comparison with the older spine APIs we had, and other things based on different technologies, really for us in the UK, FHIR is the only game in town now. That's all. Obviously, we've got lots of V2 hanging around. It's going to be there for a while, but we're not doing anything new with anything other than FHIR. So if I go back to Postman and run all those tests, if anybody's interested, I've actually got a video of this being done for real on the NHS systems as well with the same test. And they all passed. I could run them again and they would all pass except for the patient subscription message, because it would give an error message saying that there's already a subscription for that patient. But I can rerun those tests. And then I can go and look, if I can find which screen I'm on now. Look at the messages. I've already got it open, haven't I? Reset that. And I now have all of the FHIR messages that have been sent through to the event management service. So let's pick one, go and have a look at it. And we've got lots of events tracing going on. But that's the message. We've got the FHIR request coming in. Now, all of the FHIR messages are stored as streams, so you can't actually see them in the message traces very easily. So I've turned on tracing, and what that's showing me is the location of that bundle in the FHIR repository. And this is where I just have to promise you I'm doing this for real. Because of the OAuth, I can't access that page directly. So somewhere I've set up an unsecure path to the same FHIR repository just on my laptop. Yeah. That's my SSL. Every time I generate the test environment, it generates a new test certificate. So that's the actual bundle that was stored. Zoomed in too far. And if I look at the message trace again, we can see that we got the FHIR bundle. We then run through all of the subscriptions that have been created, seeing if any of them apply to this message. And in this test case, obviously, I've only created one subscription, so that's the test. And it's looking to see if the patient has that particular NHS number. In this case, it does. So it returns the endpoint I need to send the message to, and then sends that FHIR bundle off to the subscriber, which in this case is my other FHIR repository. And I'm a little bit short of time, so I'll not go and dig into the other FHIR repository and show you the message actually being received there, but it's there in the other IRIS for Health FHIR repository. And really, that's it. Conceptually, it's pretty straightforward. We receive messages, we figure out who wanted to receive them, and we send them on. But that enables organizations to receive those messages without ever actually needing to know anything about any of the other organizations at all. They just need to know which messages they're interested in or which children they're interested in. And that enables more systems to join very easily. But that's it. So if you have any questions or you'd like to see any more detail, obviously you can catch us afterwards. I forgot I was using that mic. Pat did ask me to draw your attention to the blue questionnaires you have there, which is your opportunity to give us feedback about our FHIR implementation and what you would like us to focus on. You know, we're doing a lot of work developing FHIR, but it would be really helpful for us to know which areas, which aspects of the profiles that you are most interested in working with. So if you could fill in those questionnaires, it would be much appreciated. And if anybody has any questions for Jeff or me.
My engineer's in the room. He might know this without me asking, but you mentioned something about when it sends out a token and then it would come back failed because you had already sent a subscription.
Yeah.
Is that like if a person goes to the office, they run a FHIR and then they go to another office and they run it again, even though it's a separate office, is that a period of time that it says this already has a request out on them, or how does that work?
Okay, that's a good question. We've got two different scenarios. The scenario I was talking about was actually creating the subscription message. So it's part of our implementation of our event management system rather than the out-the-box functionality. But if a provider or if a subscriber tries to make a second subscription for the same information, when that subscription already exists, then they'll get an error message back saying you've already done that, rather than having two subscriptions, potentially sending it twice.
Okay, so it's not locking down the record or anything for someone. Okay.
No. However, one of the things I didn't mention was in terms of updates. If we sent in an update message and then received an identical message afterwards, whether it's a short time or minutes or hours later, because the source system has just sent it again, then we do have actually a comparison with the history in the FHIR repository. So we can say, actually, that's a duplicate message. We can discard that rather than storing it twice.
Great, cool. Thank you very much.
What version of FHIR you have available with the IRIS?
Right now we're supporting DSU2 and SU3. I know Pat can actually talk.
Yeah, we'll be supporting R4 in 2020.1.
R4 in 2020.1.
Okay, thank you.
Mm-hmm.
Are there any tools available from InterSystems that would help us migrate from HealthShare or Health Connect to IRIS Health, like FHIR-based stuff? Because the implementation in Health Connect and HealthShare is totally different from IRIS Health for FHIR.
I was in the last session about Health Connect.
We actually have the product manager.
Yeah, go ahead. Yes. So for IRIS for Health, yes, there is. We're working on a direct conversion mechanism to go from Health Connect to IRIS Health. So it's coming very soon, but if you want to upgrade now, and there is a way to do that manually, like manual migration, and soon we're going to have a complete conversion.
Yeah.
Thank you.
But the Unified Care Record in full HealthShare is a read-only repository at the moment. So we create a composite or unified care record from multiple data sources in our own canonical format and provide the FHIR query interface on that, so you can retrieve that information as FHIR. But at the moment, it doesn't have kind of the ability to put FHIR unless you specifically create it for a particular data source. Thank you very much.